Hello, welcome back. In this session, we are going to look at the RAG hybrid search. So far, what we have seen is a dense retrieval. That means we are converting the user query into embeddings and then trying to get the chunks matching embeddings from the vector database and then giving it as a context to the LLM. Right? But dense retrieval always looks for the meaning, the semantically, the chunks just semantically similar to the user question. But sometimes we also require some exact keywords. Like if you're asking about Apple or Nvidia, Tesla, the year 2024, the AI, maybe something about autonomous cars, you are looking for some exact keywords, the chunks which are matching. And then the hybrid search gives you the best of both worlds. It will get the words keyword matching using the sparse retrieval. It does the semantic matching using dense retrieval, combines both of them and ranks them and then pass it as a context to the LLM. In this session, we are going to understand first what is a hybrid search, how it works, and then we are going to see that in the action. Now let's see how the hybrid search works in action. So before that, we need to understand what is a dense retrieval and then what is a sparse retrieval. So dense retrieval is what we have seen so far, that is getting the matching chunks from the vector database, doing a semantic search. So we convert a query into embedding and then we do the cosine similarity for the matching embeddings. In sparse retrieval, we do something like use a term frequency and keywords to find the matching chunks. So take an example. So if we say a Tesla's 2024 revenue growth is a query, dense retrieval will find Tesla's financial performance improved significantly over the last fiscal year. It is good semantic match but may not mention the year and the revenue explicitly. In case of a sparse retrieval, Tesla's revenue is 24 reached 95 billion. So it finds exact match for the year and keyword, but without any explanation or context. So if you combine both of them, you are actually combining the data, the context you provide LLM is well grounded, which will reduce the hallucination. So before we go into the process of hybrid search, first let's understand, since we already know dense retrieval, let's understand what is a sparse retrieval, how it works. So we use something in this example, I'm using something called BM25 sparse retrieval algorithm, which stands for best matching 25. So it ranks a document based on how often a query term appears, how rare those terms are across the corpus, and how long the document is. Let's understand this TF-IDF in more details. Say for example, the user query is AI regulations and the document retrieved is AI is transforming industries, AI regulations is growing globally. In this case, you see the TF means measures how often word appears in the documents. In this case, AI appeared 2 times, regulation appeared 1 time. So the high TF means high relevance. IDF measures how rare a word is across the entire corpus. So something like a report has got low IDF but regulation having high IDF. So more important if the word is less common. Then the document length normalizations. So you try to avoid giving a long documents in unfair advantage. How do you do that? For example, a 20 words mentioned AI once, it is more focused, but 200 words mentioned AI once, it is less focused. So BM25 favors A due to better signal to noise ratio. Now let's compare this. We'll go to the step by step of how this works with an example. But before that, let's see what is the difference between sparse versus dense retrieval. Right? One thing is that the sparse is more of a keyword. It doesn't handle synonyms. Like, if you can use, in case of a dense, you can use what is Tesla's revenue or Tesla's sales or Tesla's, profit or, top line, bottom line. You can use all these words. It can still figure out that you are asking for a revenue numbers, right? But a keyword will not be able to handle that. And if you're having some typos, most of the time dense retrieval can handle, but not the sparse retrieval. But this is sparse is great if you want to check for exact numbers, like you want to check for the year, you want to check for the figures, you want some named entities. And dense is mostly for very paraphrase sentences or some vague concepts. As I told, as we see in the last example, Something like Tesla's revenue 2024 is exact match, but how much money did Tesla make last year? The sparse retrieval might not fetch, but the dense embedding will fetch you that. And again, the storage is we store in a vector database. In this case, we store an inverted index, something like Elasticsearch. And now let's see the step-by-step workflow of how hybrid search works. So let's take an example. So our query in this case is Apple's AI investment in 2024. So step number one, dense retrieval, which is doing a semantic search. So this query is, then we convert this query into embeddings. We go and then get the embeddings which are very similar to this. That means we do cosine similarity to this sentence. So for example, we got 4 chunks based on the ranking. These are top 4 chunks, 1, 2, 3, 4. Now we also do the sparse retrieval using BM25 search. Something like, now this will look for Apple AI 2024 investment, this type of words it will look. It has got me these 4 chunks. In step 3, I combine the results with a reciprocal rank fusion, RRF. So what is RRF? Is a simple but a powerful method to merge 2 ranked lists using their rank positions, not the actual raw scores. So how does it does? It computes RR score, like sum of 1 plus k by rank. This rank k is a fixed term. It could be something like typically 50 to 60. 60 is a common the thing we use. Now if you see this example RRF, it computes a dense rank and sparse rank and what is the combined RRF score for each one of them. Now I'll pick up top 3, say I'm taking top 3 or top 5. I'm in this case example, I'm picking up the chunks with top 3 score. Now we can see that Apple is integrating generative AI in this, it is having this. Now you can see the question asked is, what is Apple AI Innovation 2024? Now I'm actually getting the semantically similar and also the exact terms, like in 2024 Apple invested 1 billion into generative AI research, right? So this is what, and after applying re-rank, I pick up top 3 or 5 chunks and then I'll pass the chunks as a context to the LLM. So another advantage of what we are using this reciprocal rank fusion or RRF is that, so depending upon, it uses only rank positions, okay, and it doesn't have, if it basically does the merging of different results and you don't require a separate model training. So that's advantage of using this RRF scoring. So again, there are some use cases when you should use hybrid search, some other considerations. So use hybrid search, for example, typically for a document like a 10K documents, a legal contract, some scientific publications, where you require both a natural language or a keyword. Something like, FDA approval for Alzheimer's, right? Sparse will find the drug names, dense will get the policy context. So you require both of them. In that case, it makes more sense to use a hybrid search. So the consideration that you need to maintain 2 indexes. You need to have one dense, which is like Pinecone or Waveit or Quadrant, like FICE, all these things, and you require a sparse, which is like Elasticsearch. And then you need to choose your fusion score. Either you can do it weighted sum of scores or you can use a RRF. And then we need to make sure that both retrievals are scaled fairly. Maybe you can use something like a normalize or maybe 0 to 1 or z-score like that. And we can use some, we'll talk more about this evaluation metrics later, about context precision, faithfulness, groundness. So when you have both precision plus context, that's where the hybrid search will. Now let's do a code walkthrough. So we are creating a sparse retrieval, which is a BM25 retriever we are creating. This will take the documents. These documents is what we have created initially beginning of the cell, right? We take the PDF files, we chunked them, and then we created this documents chunks. Obviously, if at all, you can also use something like Elasticsearch, but in this case, I'm just having all the chunks of documents and I'm trying to create a BM25 using that one. So first thing is that we have to tokenize this documents for BM25, and then we build the BM25 index. So this is what our index is going to be. Okay. Next, we have this retrieve function, which will take the query and say how many top results you want. It will tokenize your query, and then it passes this tokenized query to BM25 to get the scores, and then gives you the top K results, right? Then, of course, this is some of a backup method, get early method, backup method. Let's see how. Then I just a simple testing we are done. Like for example, we are passing some revenue growth, financial performance. Let's see what is the the chunks we get matching this particular query, because now it is querying again, not against a vector database, it is querying against our BM25 index we created. This index is created using the documents. Like we are taking the same document chunks. One set of document chunks are going to a vector database by into embedding. The same document chunks we are saying, we are also creating a index out of it. Right now, let's execute this. Now we can see that it is tokenizing the document. It is building BM25 index. It has built that. Now it is testing this one. It is able to retrieve 3 documents. One is Amazon and Nvidia, because wherever it is finding revenue growth, financial performance, it is pulling up all those chunks, right? Of course, I'm just doing only top 3 chunks I'm retrieving. Now let's see the hybrid search. So in case of hybrid search, I'm passing the query string. I'm passing dense retriever, which we have all defined in the beginning of this notebook. And then I'm also passing BM25 retriever, and then LLM, and then top K, right? Now, what is the first thing we do? We are actually taking the query, we using the embedding model, we're creating the query embedding, and then we are hitting that with the vector database querying, and then getting the top 10 results, right? This is the dense embedding. So we are getting the dense response. I'm actually printing my dense retrieval, what all chunks I got, metadata, everything I'm printing. Next, I'm taking the same query. This query, I'm actually hitting the BM25, which is our BM25 index it is hitting. That is giving me some document. Okay. Now, I have 2 documents that I received, one from the dense retrieval, one from sparse. Now I'm applying the reciprocal rank fusion on this. So my RRF constant is 60, and then I'm actually doing this, like I'm applying this formula 1 by RRF plus rank, K plus rank. I'm applying this formula for everything, and I'm computing like what I saw an example, like computing the RRF rank for each one of them. And then I'm actually sorting the RRF and then getting the top K results. And then I'm actually just printing all my RRF results, and then passing this as a, and rest of the thing is regular, like what we have done so far. Pass this as a context to the RAG application. Right now, let's execute this and see what happens. So let's see this trace. So you can see that I first got dense retriever. So I got this document. Now BM25 retriever gave me these chunks. Now applying the reciprocal rank function, I got RRF, it also find some duplicates, so doing some combined score. Now it has got around 19 unique documents. It is picking the top 5. You can see that 0.31 is RRF score is the top, and again it is picking the document based on the RRF score, and then it has displaying the answer. Right now we can see that in this answer, what is our question we have asked is this one, what fact did Amazon cite for declining profit margins, right? So it requires both. I don't want to get the documents related to Nvidia, Tesla. I want specifically Amazon, and I also want something semantics in that. That's what we did. Now when we see the answer, you can see that it is actually properly categorizing the risk cited by Amazon in the entire 10K document. So this is about the hybrid search, where we have seen in action how to do the dense retrieval, how to do the sparse retrieval, do the RRF ranking, and then pass it as a context to the LLM. So this concludes the hybrid search. Thanks for watching.